So I'm having cohort A join us today because I'm going to teach a lesson.
I'm going to record it so they can always. Let me. I'm going to put this here. Hopefully that works. Let me freeze this for a second. Make sure. Yeah, I got you guys in my ear. Good. All right. For those of you that are joining me at home, in the chat, just say something. You can just write your name or say hi, so that I can take attendance. If you haven't checked yourself into Infinite Campus yet, if you already checked yourself in, then you're good, which is most of you. But there's a couple of you that haven't yet, so make sure that you do that. And in a minute, I'm going to change my camera to be my better webcam when I move you guys over, and the quality of the video should be a whole bunch better. But you can mute yourselves. You can ask questions. Just unmute yourself so I hear you. I'm just going to wait a second. I'm waiting for Chase to get back before I get started. But how did that 1.1 go? Did we get that uploaded? I mean, even if you didn't do great, it's not the kind of thing where I'm going to like completely check for correctness. It's going to be effort, completion, and correctness for sure. So make sure you get that uploaded. If you ever have any issues uploading to Canvas for whatever reason, you can always just like I was telling kids, you can just email it to me or just bring it into class the next day. That's fine too. We just want to try to avoid that. Johnny, just mute yourself, brother. Okay. Let's share this screen so you guys can see what's going on. And then once I start the lesson, we'll kind of go from there. I'm gonna put you guys back in my ear. Okay, cool. All right, so yesterday, we'll start with yesterday. Seniors, hope the SAT went well. I looked a little bit at the math section. Some easy questions and some hard ones for sure. Maybe some things you maybe haven't seen yet before, but wasn't too bad. So hopefully now it's done, it's behind you, so that's good. For you guys, for everybody else, wanted to make sure you got that quiz 1.1 uploaded, good to go. It was kind of a catch-up day in case you needed one. I wanted to kind of take a little bit of pressure off us, because we're going to turn the page. The quiz 1.1, like all of the key features of functions, done, behind us. Okay, it's time to keep rolling. So, however, I did not hear from everybody that I know got some help outside of their notes on that quiz, which means next Tuesday in class, we're doing it again. And it's going to be a new quiz, new questions. Okay. You're going to bring your old quiz in with you. I want to see that old quiz. I just want you to bring it in with you because it's going to go in the recycling. I'm not using it anymore, so you don't get it anymore. It's gone. Okay, new question, so you don't get to use that to help you out. Okay, so next Tuesday in class, and that's all the time you get. Okay, if your accommodations allow you that time and a half, then we can start early during lunch. Okay, you will come in for that extra 25 minutes if you get time and a half, or the extra 50 if you get double time. Okay, so if that's you, if I'm talking to you, then plan on that, or plan on, well, so the problem, I can't stay after school. You can do it early. You can come in early, but I can't stay late. Okay, I took my kids from daycare early that day. So cohort A, that's happening for you at home on Monday. I'm talking to you guys. So quiz number 0, we're going to try it again. And from here on out, because now I have, like the trust is broken, all the stuff that we do for correctness happens in here. I can't send stuff home to you until I can trust you again. What I found out is that the results from the quiz, a completed version, ended up on Snapchat. And well, I'm not going to say it because I'm recording it, but that's BS. That is baloney. Okay, that cannot happen. Okay, I don't know where the disconnect was between how I presented the way that this class is going to work and how you took that. So we've got to mend some fences here big time. You're good. I just want to grab my stuff. We've got some fences that we need mending. Okay, so Tuesday, cohort B, quiz number 0 again, because people cheated. Not enough people came forward. The people that I know cheated did not step up, and I found out that because the answer showed up on Snapchat, that the one question I was really worried about turned into 16 questions that I had to worry about. And so it sucks for the people that didn't cheat. I apologize to you, but guess what? Don't blame me. Blame the people in class that cared so much about an open note quiz that they cheated and shared their answers. Doesn't fly for me. Okay, so next Tuesday, cohort B, you guys, and in my ear, cohort A, we're doing it again. Okay, so I will put that up as a reminder on Canvas so you know it's coming, but all those grades are getting wiped out and we're starting fresh. And that's what I want to do. I just want to start fresh. Okay, we're going to turn the page. I'm putting it behind me. Right? I'm not mad. I'm just disappointed. So, all right, new topic starts today. Okay, we're going to do 1.2. Now, what I want to do is I want to be able to get everybody at home to see me. So what I'm going to try to do, I think the best way to do this, I disconnect here, but I do need this to charge. So I'm going to bring this over. And nice, that does fit good. And my new webcam, which is awesome. The quality is so much better. Just give me a second to get it set up. Okay, so no need to present. I am recording. Good. I just got to change my settings. So the video goes through there. Nice. All right, I'm going to pin it so I can make sure things are good. Move it a little closer so you guys get the best view possible. And this is being recorded so that if you need to go back and look at stuff, this is just going to be kind of new. The stuff that we're going to do is just going to be a little bit different. Okay. It's not ideal because I would love to show you some stuff. Man. So I might have to bounce back and forth a little bit between here and the projector, but I might just end up just turning my computer around to you so you can see it. Okay. All right. 1.2. Take us on the right way, something to write on. Okay, we got some new stuff coming at you. Still on the visual side, bless you, of things, but we don't have to do. We don't have to like look at graphs and describe them. We're going to look at the equations themselves and figure out what's happened to those graphs. So what I'm going to do on my laptop here is I'm going to pull up my own graphing calculator. If you've got a graphing calculator with you, or if you've got your phone with you, so graphing calculator is best. But if you've got your phone, go to Desmos if you have the app, or just go to desmos.com so you can visualize exactly what I'm visualizing. Because it's so much easier for this stuff to make sense, for you to believe what's happening if you can see it. I'm a super visual person. I get the most out of whatever I'm doing if I can see it in action. You tell me something's happening, it's hard for me to believe. But if I see it with my own 2 eyes, there it is. Okay, now I feel confident. Now I feel good about what's going on. And what we're going to do is we're going to talk about how can I take different kinds of graphs and move them around. Slide them left, right, up, down, flip them upside down, make them skinnier, make them wider. And it doesn't matter what kind of shape I look at. We're going to look at what are called transformations of any kind of function. So transformations of functions. Okay, I know it might be a little bit tricky to read at the top there, folks at home. So that just says transformations of functions. Let me take attendance while you guys are getting stuff right now. We should have 14. Let's see, 4, 8, 12, 14. Oh, we're missing somebody. Calvin, Trevor, Jackson, Stone, Sam, Alex, Josh. There it is. Okay. All right, transformations of functions. But if you have Desmos up, we're just gonna, I think it's just easiest to see if we look at one kind of function, but it works for all of them. And what I want to come up with is a really good way to tell. How do we know that if I took just a basic function and I don't know, let's just call it, I'm going to call it f of x equals. I don't need the y equals. It means the same thing. Let's just look at x squared. Now, it works with x cubed, it works with absolute value of x, it works with the square root of x, it works with all of them. But x squared is an easy way to take a look at what's happened. Do you know what kind of function that is if it's x squared? Don't we call those kinds of functions that have a power of 2 as the biggest, or in this case, the only exponent? Starts with a Q. Close. Quadratic. Nice. Same kind of beginning part of it, quadratic. Now, x squared, what does quad mean, though? 4, right? I drive a four-wheeler, right? It's quad. So why 4? Well, x squared. How many sides does a square have? How many of those are all the same length? That's what it's called, quadratic. Okay. Now, but like I said, it works for any of them. Do you know what that graph looks like when we actually like put it on a set of axes and plot all the points? Good guess, though. So this is like the name of the function. But the shape that it makes? Because just visualizing it is just a whole lot easier. You guys remember? That U-looking shape? Remember what that's called? Nice, bravo. And this is the only kind of function whose shape, name, and like the name of the function are different. Like absolute value is called absolute value. Like a cubic function is just x cubed. So this is kind of the only weird one, which is why it's a decent one to start with. And so if you jumped into a calculator, I'm just going to present real quick so people at home can see what I'm doing on my laptop. And I'll turn it around so you guys can see. If I just go to my calculator, or you go to Desmos, right? You can just type in the equation. I'll blow this up. That's a one from calculus. We'll get rid of that. If I just type in x to the second power, and I graph it, there it is. All right, the blue. And what I want to do is I just want to mess with that. I want to change the way that looks. I want to slide it left, slide it right, slide it up, slide it down. And so what I'd like to do, man, how can I do this more? It's kind of a pain that I had to do it this way, but we got to do what we got to do. What I want you to do, because you should all have at least a calculator or a phone in front of you. What I want to do is I want to compare a couple things. I want to compare this one, and let's just call it y, because who cares? I want to compare that to y equals x squared plus 3. What's up? Okay, what is it? Right, so sometimes we see weird shaped windows. Check this out. Right, he's obviously not seeing the shape that he should. He's not seeing that parabola. It's because the way his window is kind of focused. Right, you can zoom in to whatever spots you want. Like you can pinch and zoom on a Google Maps or on a photo. There's a really easy way to get yourself back to a nice window. This goes for everybody, but at the top of your graphing calculator, all those buttons are all graphing buttons. Okay, y equals on the left and graph on the right, but in the middle says zoom. Press zoom. Option number 6 is zoom standard. That's -10 to 10, -10 to 10. It's a great window to start in. I don't know why they don't put it first. Well, I do. Option number 1 is really cool. Zoom box is awesome. We'll play around with the calculator a lot, but that should get you back to a nice looking window. Okay, but so I want this one. Let's call this y1, and let's call this y2. Have both equations, y equals x squared and y equals x squared plus 3. And the nice part about these newer calculators that have the color is that you can really tell them apart. And then just press graph. And it should look something like that. If you're comparing both, because that's the way to do it. Don't just look at one at a time. Go back to the original and compare it to something different. So the blue one is the original one. The red one is the new one. What would you say happened? How would you describe the change that happened between x squared and x squared plus 3? So it moved to 3 on the y-axis. So is that a change up, down, left, right? Up, right? What's a kind of a fancy way to talk about changes that happen up and down? What's a good word that means up and down? Vertical, nice. Okay, it's a vertical change. And so adding 3 at the end moved it up 3 spots. Okay, well now compare that. Let's go to y3 to like x squared minus 4. And just describe the change that happened from the blue, and in this case, to the black. Going back to the original and changing it to the new one. X squared minus 4. Went down. How far do you think it went down? Probably 4, right? Whatever that number was is going to tell you how far things change. Okay? So when we add and subtract a number kind of just on the outside, right? At the end of this equation, it moves the graph either up if it was plus or down if it was minus, which makes a lot of sense, right? Don't positive numbers go up and negative numbers go down? Absolutely. And so that kind of change makes a whole lot of sense. I believe it. I see it. The change that happened from x squared to here is vertical. It went up. How far? It went up 3, right? This is vertical. How far did it go down? It went down 4. Do you believe that? Does that feel like it makes sense? Like visually, it kind of sticks, right? So what do you think? Don't even type it in. But if you had to talk about x squared plus 5, how would you describe that change without even looking? Vertical for sure. Where did it go? Up 5. And so I just want a good word that means moved, like the whole thing. I just want like a single word that means, okay, so vertical something up 5, or vertical something up 3, or vertical something down 4. But it could be increase or decrease. So I want a word that just means to move. Translation is the fancy way of saying that. I'm good with a word like shift. But the word to translate, a translation, is a really fancy way of saying the exact same thing. I'm good with shift. I'm probably going to use the word shift more frequently than I will translation. It's shorter. Absolutely. Yeah. I'm going to say shift. Translation is awesome. That's even better. Okay. And so remember that word. Now that happened when we used addition or subtraction. And I'm going to get a lot of stuff down kind of as we talk about it. And then I'm going to move over here and I'm going to give us the whole thing in one spot. Okay, so you can write all this stuff down if you want to, but really, I'm going to make it super organized right over there once we get there. Okay, all right. And that change right here, that one was vertical. It was a vertical shift, and it happened in the direction we would expect. Plus 3, up 3. Down 4, minus 4. All words. Okay. Now, clear out everything except the original. In y equals, clear out everything. So for me, my y equals looks like this again. Just plain old x squared. Okay, but it's still there. My y1 is still x squared. Okay, folks at home, you should be able to see both. You should be able to see the camera and my screen. So I hope that that's working out for you. Okay, but I just wanted you to see it. But what I'll probably, I'm going to stop sharing. I'd rather you see what's up on the board. Okay. I want to do the same kind of thing. But I want to do that plus or minus. I want to put it somewhere else. So my y1 is still x squared. But I want to make a change, not kind of like at the end of this function, but not at the beginning, because what's 2 plus 3? What's 3 plus 2? Does the order matter when I add? No, it doesn't matter, right? So I'm not going to just change the order. I'm going to change where it's happening. What I'm going to do is I'm going to put it inside and keep the squared on the outside. I want to do x plus 3. I'm going to use the same numbers. but I'm going to put them somewhere else. And so do it. Go to y2. So have y1 in there, because you got to be able to compare back to the original. Go to y2, parentheses, x plus 3 squared. And let's see what happens. I'm going to share again. And keep going back and forth. I mean, let's just look at it first. Is this equation in purple with the plus 3 the same as this equation in the green with the plus 3 on the inside? No. They don't look the same, so they're probably not going to give us the same result. And so take a look at the graph. There's my blue one, the original, and there's my red one. Did that graph move up 3? No, and it's because it's a different equation that has different results. Which direction did it move? Moved horizontally, but was it left or was it right? It went right. But doesn't plus 3 kind of feel like going right on the number line? Don't positive numbers go this way and negative numbers go this way? Horizontal shifts are backwards than you might expect. They're going to go in the opposite direction. And just like range is the only weird thing about key functions, horizontal shifts are the only weird thing about transformations. They're going to happen in the opposite direction than you might expect. And so if we did x minus 4 squared, do you think it's going to move it down 4 like the purple one did? It's probably going to be a horizontal change. What's the axis called, the one that runs left and right? It's the x-axis, right? And look where the change is happening. I'm changing x. So that's like moving in the x direction. But to me, negative feels like this way. So which direction are we going to go? We're going to go the other way. Okay, horizontal transformations are backwards. But because it's still connected by addition or subtraction, it's still going to be a shift. It's just going to happen in a different direction. Okay? It's just going to be backwards. So, you tell me, x plus 5 squared. Is that the same one as this one? The purple one? No. It's, the plus 5 is still the same, but it's happening in a different location. All right, x minus 4. Let's do the x minus 4 squared. Let me show you that graph first. All right, so the red one was the x plus 3. Look at the black one. All right, horizontal shift, right. All right, there it is. Moved over in the opposite direction than we might expect. Okay, now let's try that last one. So I'm down in y4. X plus 5 inside the parentheses. Insert a 5 there. Horizontal or vertical? What do you think? Horizontal, because it's inside changing x, and the x-axis runs in the horizontal direction. Is it a shift? Absolutely, right? I'm just going to take every point, I'm going to translate it, I'm going to slide it, I'm going to shift it, all of the points in a certain direction. Because it's plus, to me, plus feels like this way. Positive numbers go this way. So which way am I going to go? I'm going left. I'm going left. Okay. How far am I going? That far. Okay. And so what I'm going to do, you come with me.
All the square does is make it a triangle, right?
It's all good. Yeah. So the type of function it is, the exponent takes control. But where the function ends up, that's going to be the addition or subtraction so far.
Are you on this board?
I'm going to that. Yep. And I'll give you a chance to see what the picture looks like so you know if you're in the right. But I do have to turn off the present so everybody can see. I have to turn on those lights too. Okay, so what I want to start doing, and I would kind of create a space that's about half a page large. Because what I'm going to do is I'm going to give us a really easy, nice flow chart to follow to help us figure out what kind of transformation we're dealing with. Okay. All right, so I know it might be tough to see at the top, people at home. This says transformation flowchart. Now, I'm going to take up this whole space here, okay? But I don't have enough information to fill it up yet. We only have shifts, okay? But there are, honestly, there's only 4 decisions that we have to make when it comes to transformations, okay? The first decision that we are going to make, and so this says 1, 2, 3, 4 at the top here, folks at home. 1, 2, 3, 4, and you can use the whole page, go all the way to the left, okay? The first decision that we have to make is whether it's horizontal or vertical. Okay. The words in green are what we're going to say. The way that we're going to figure out what words to say are going to be a different color. Okay, so you're going to say what's in green. We're going to decide which one by what I write down here. And if you look back to the work that we've done so far, the purple to the green, really the only difference that made it vertical versus horizontal is where the change happens, right? Where is the change? Right? From plain old x squared, or x to the third, or absolute value of x, or square root of x. I don't care what kind of function it is. We're always going to use x squared to start. It doesn't matter. I just want to talk about the transformations. What has been different? If it was a horizontal change, the ones in green that are over there, where did we put the +3, the -4, the +5? Inside the parentheses somewhere, right? Now, it could be inside parentheses for x squared, or inside parentheses for x cubed, or inside those absolute value bars, or inside the square root, or wherever. If it's a horizontal change, it is inside, like, and I'll just put parentheses for now, right? Inside the parentheses, and we need to be changing x to do it. If I want to make a change in the x direction, it better happen to x. Okay? I'm going to say the word horizontal as the first way that I describe the change. Or I'm going to say the word vertical if the change was happening somewhere else. So look at the ones in purple. Where were those changes happening? Were they happening inside some set of parentheses, inside some square root? The ones in purple? Not inside anything, right? So let's just say outside the parentheses. Happening like out in front or at the end, I don't care. Could be first, could be last, but it's got to be on the outside. Okay? And once we make that choice, step 1 is done. I'm good. It's a vertical change or it's a horizontal change. I'm going to write one of those 2 words down first. Okay? Then it's up for me to decide what type of transformation it is. And so far, what type of transformation? As of right now, the only one that we know, so here it is in green, because that's the word I'm going to say, shift. 4 translations. So that's a good. Okay. How do I know it's a shift? Because the way that the number, whatever that change is that's happening, the way that it's connected is addition or subtraction. Addition or subtraction of a number, Okay. Now, there's other kinds of changes that we can do, but I want to focus on shifts first. And I'm really going to emphasize the F in that word so it doesn't sound like something else. Horizontal shift. A lot of F's. All right, cool. Now, there's a big difference between going up and going down, going left and going right, and that's the next decision we make, but I only have to make that choice if it's a shift. I told it's a flow chart. If you say horizontal shift or you say vertical shift, the next words that are coming out of your mouth are going to be very different than when we look at, so there's going to be 1, 2, there's going to be 3 different types of transformations. Okay? If you say shift because it's connected by addition or subtraction, now it's time to decide what direction. Okay? Okay? And it could be left, right, up, or down. It could be a horizontal shift left. Could it be a horizontal shift up? Horizontal shift up? No, right? So as soon as you make this choice, whether it's horizontal or vertical, you're restricting your options for number 3 here. If it's left or right, it has to be horizontal. You had to have said horizontal first. If it's up or down, you have to have said vertical to do it. Okay, so I can't say vertical shift right 7. It just doesn't make any sense. Now, when we did those vertical shifts, the first one's in purple there, when we did +3, did it move in the direction that we expected? Did it go up? The vertical ones did. The vertical ones went in the direction I expected. +3 to me sounds like plus. Let's go up, right? -4 was a vertical shift down 4. Your vertical changes are going to happen in the direction you expect, okay? I'm going to call that intuitive. They're going to happen in the direction you expect. They are going to follow your intuition, what you would expect to happen. My intuition is that when we show up on Tuesday to take this quiz, that there's going to be far less opportunity to cheat than when we take it home. That's my intuition. That's what I expect. Vertical changes are intuitive. Horizontal changes were backwards. They did not happen in the direction I expected. Like, to me, when I add stuff, I feel like I'm going this way on the number line when we're going X, right? Because positive numbers go this way. But what direction would you go? We went that way. And when I subtract numbers, I feel like I should be going this way on the number line. But what direction did I go? I went the other way. So what is the opposite of intuitive? I don't know if you know it. A bad choice. Extuitive. Horizontal changes are counterintuitive. They go in the opposite direction than you would expect by looking at the plus versus the minus. Sure. So horizontal shift left, horizontal shift right, vertical shift up, vertical shift down. Again, the words in green are the words we say. But the words in this magenta color, those are the ways we're going to choose the correct word. Okay? Now, once I make that choice, whether it's left, right, up, or down. So when we call this one over here a vertical shift up, what do you think the only other piece of this is what matters? Vertical shift up, vertical shift down. We want to really describe what happens. What matters? Is a vertical shift up 3 the same as a vertical shift up 10? The number, whatever it is. How far did it go? And that number takes control. Okay. Horizontal shift left or right, however far. Vertical shift, upward, down, however. Okay. Let's try it first, because this is the way that these questions are going to look. They're going to say, here's some function. Let's call it number one. Here's a function. Describe the transformations that have happened to this function. So let's call it a little f of x. Sure, why not? F of x equals x squared plus 6. And we're going to describe these transformations. We're just going to use that flowchart. Okay, x squared plus 6. I want to point this back here for a second. Okay, and we just have to make a choice. 1, 2, 3, 4. Is that change horizontal or is it vertical? How do you know it's vertical? Right, this color. The change that's happening is outside the parentheses, so the only word I have to write down so far is vertical. Okay, what type of transformation is it? And it's because it's connected by addition or subtraction. We don't know any other ones yet, so for sure, plus 6 is attached by addition or subtraction, so the next word I write down is shift. What I'm writing up there, the answers are short and sweet. There's really no work. Like, there's no like algebraic stuff you have to do. You have to just recognize how to know the changes that are happening. And so we've done a lot of algebraic stuff so far. I wanted to kind of switch gears a little bit. And it's nice that it does it kind of sequentially in 1.2, start talking about transformations. Okay, first word, done. Second word, done. Third word. We said vertical. What are our only two options for what direction we're going in? Can only go up or down. Vertical transformations follow your intuition. They go in the direction you would expect them to. So this is kind of where you look at the plus versus the minus. That's what we have to look at here. Now, because it was addition or subtraction no matter what with a shift, but now there's a difference between plus versus minus. So it's a plus. It's vertical. It's going to follow our intuition. What direction do we think it's going to go? Up. What's the last thing? And what is that number? There's your answer. Vertical shift up 6. That's it. That's the answer to that question. Describe the transformations that have happened. Number 2. G of x. Who cares what letter I use? I got to use something different because I'm talking about different functions. Let's go x squared minus 7. Simple function. But all I want to do is take a look. Let me pull this back here for a second. What I want to do is I want to take a look at the changes that have happened. I've got that x squared minus 7 as my equation. Okay. And what I want to do is I want to figure out what changes have happened. So I just go to this. This does it all for me. Okay. Horizontal or vertical?
Vertical.
Where is the change happening, inside or outside? Outside, there's no parentheses, so I can't be inside parentheses if they don't exist, right? That's an easy one. I know it's got to be vertical if I'm adding or subtracting or doing whatever it is on the outside. First word to write down, vertical. Okay, what type of transformation is it? It's addition or subtraction that connects it. I know that it's going to be a shift. Now, we said vertical, so it can't be left or right, so our only option is up or down. It's going to go in the direction I expect. It's a minus. This is where we differentiate between pluses and minuses. Okay, down. How far? Done. Don't say down -7. The down took care of the minus part for us. Vertical shift down 7. So we did f of x and g of x. Give me another letter. C of x for Calvin. How about that? C of x. Now, parentheses, x minus 1, parentheses, squared. The first choice we have to make is horizontal versus vertical. How did you know? Inside the parentheses. The change that's happening, where the number is being added or subtracted, is happening inside the parentheses. There's nothing on the outside. So the first word that I'm going to write down here, horizontal. Ashton. Sure. What kind of so number 2, what kind of transformation is it? We only have shifts so far, so we know for sure. But the way I definitely know for sure is because it's connected by addition or subtraction. We said horizontal. Could it be up or down if we said horizontal? It's got to be left or right. But to me, when I think about plus and minus in this direction, minus happens this way. So which way are we actually going? The other way. Okay? Horizontal transformations are counterintuitive. They are backwards than the way you would expect. We're going to go right. How far to the right are we going? Whatever that number is. Okay? One more. I'll put it right here. E of x? I like it. E of x, parentheses, x plus, let's pick a new number, 2. X plus 2 squared. Now, the squared isn't a transformation. It picks the function we're looking at. It makes it a parabola versus a line, versus absolute value making a v, versus a square root. I just care about the addition or subtraction that's happening. Where is that change happening? Inside or outside? On the inside, changing x, it better happen in the x direction. It's got to be horizontal. Step 1 done. Step 2, what type of transformation is it? It's a shift. It's the only one we know. But I know for sure that it's going to be a shift because I'm connected by addition or subtraction. But now it matters whether it's plus or minus. And plus to me in this direction feels like this way. So what direction are we going? The other way. Okay, counterintuitive. We're going left. How far left are we going? Done. Got the hang of it? Okay, cool. We've got time. Let's keep it rolling. Here's where I'm going to share again. And I want to do something different. We've looked at all of the shifts that we possibly could. We've looked at all of the places to add or subtract numbers. So what do you think we're going to start doing if we've taken care of all addition and subtraction? Let's multiply and divide by something. Now, it's still going to be plain old x squared to start, but let's compare that to, like, I don't know, 3x squared. Let's multiply by some number. So if you've got your calculator in front of you, type it in. I'm going to erase all my stuff in here except for y1 because I like to go back to the original and compare it. I think once you get the hang of it, it feels really easy. But at first, like, because there's 3 different options, without the flowchart, it can be kind of hard. That's going to be, that's the only part of this that's backwards, is the horizontal stuff. Okay, calculator stuff happens. I know them pretty well. Let's see. Invalid dimension. Go to quit. Go back to labels. So you have plot 1 turned on, but we're not plotting any like single points. We're plotting a whole graph. So go up, press enter, turn it off. Now it's your graph. Okay, so what I want you to do is compare the blue one and the red one. Now, when we did all these shifts, that turning point moved, right? The whole graph moved. Does this thing still turn at the same spot? Right there at 0, 0, right? What do we call that 0, 0? It's a vertex because it's where it turns, but it's the origin because it's 0, 0. Perfect. Both are true. Okay? So I'm not shifting anything. But what would you say about the red one compared to the blue one? So the blue one was x squared. The red one is 3x squared. Say it again. The x values are changing. What do you mean? Oh, look at that. See that? See what his hands just did? Do it again. Like the shape of the graph is actually changing, right? Now I'm going to take that idea that you just did, where you moved your hand. I'll steal this for a second so you can see me. The graph was like this. It now looks like this. What am I doing with my arms when I go from here to here? I'm moving them up, huh? I'm changing the shape, like the actual shape of the graph changes. It's getting skinnier, right? But like, don't think about the math. Think about what my body is actually doing from here to here. Like, what are my hands doing? Because my arrow, like, these are my arrows for the end of this function. They're getting closer together. Good. How else would you describe what my body is doing? It's all true. You're not wrong. I'm gonna keep doing it until we get there. Yeah. So I was here. Can I reach what? Say it again. So good what? Stretch. That's the word. It's called a stretch. The word that we're actually going to say is we call it a stretch. You're going like this 100 times. Yeah, I know, right? Okay. So I'm back over here to our flow chart. All right, and what I know for sure, I should be pretty charged by now, is that if it's connected by addition or subtraction, I am guaranteed that this thing is going to be a shift. But now that we're multiplying by something, or dividing, because I can divide by numbers too, the kind of transformation that we're going to get is called a stretch. Okay. However, so stretch, but there's another option. There's another word that we could describe when I do something different. Okay, so take a look at this. What if we compared 3x squared to, like, I don't know, 1/2 x squared? And we'll make this one our last one. So we won't be done today, but we'll be pretty close, actually, which is good. We made some progress. 1/2 x squared. I'm going to share my screen. Let's see, am I still presenting? Yeah, okay, good. All right. Compare, not the red one anymore, because that was a different one. Compare the blue to the black. You know what? I'll even get rid of the red one so it's not as confusing. From blue to black. But let's talk about what my arms are doing. I'm going back to it. Make sure the camera can see me. I was here. Now I'm going like this. Now it's a little tougher to come up with the right word like this. So let's talk about what's happening to just one arm. Okay? My arm was up here, and it's like somebody did this and pushed it down. Okay? What's happening is this. It's a good word for it. Shrink isn't bad. Okay? But it's just a similar word that means the same thing. But think about this. What do you say? Contracting what? Compression. There it is. Okay? We could have a stretch if my arms are going up, but it could also be a compression if my arms are going down. If I'm getting closer to the x-axis, I'm getting compressed down to it. If I'm moving away from the x-axis, we're going to be stretching. Okay, now guaranteed for sure that the way that that's going to happen is with some kind of multiplication. Now, if you remember, like, all right, multiplying by 1/2 is the same thing as dividing by 2, right? So I'm going to lump it all together and call it multiplication, because I can divide by a number or I can just multiply by a fraction with that number on the bottom, okay? The way that I know this is going to happen is multiplication. Okay? but it depends on the number. Okay? And I'm going to call that number by just like a variable, because I don't know what that number is going to be. I'm going to call it a. So think of it like y equals ax squared. It's going to be a stretch if a is bigger than 1. About 15 seconds ago. Okay? And then we're done. Okay? It's a compression if a is between 0 and 1. 1/2, 2/3, whatever. All right, we'll pick this up tomorrow. I don't know what we're going to do tomorrow, but I probably will send something out tonight so you know whether or not you have to log on live or not. Okay, so like expect something like 9-ish o'clock tonight. I'll send some stuff out. Yeah. Uh-huh.
So when you're writing it like vertical shift up,
You guys are good to go at home. Thanks, guys.
instead of if you didn't have a stick and you had to write the number, what if you had like a fraction? Where you write the fraction?
Just a number. 1/2, 2/3, 9/15, whatever it was. Yeah, 1.7. It can be any number we want, for sure.
It's gonna be easy to write.
I think it's not that bad. Yeah, for sure. What's up?
So the group here is no longer